Hi, everyone again. I'm delighted to introduce our next outstanding speaker, Brian Ho. Is a senior product manager at Delve by Sidewalk Labs, part of Google. Hello, Brian.
Hello.
Is an interdisciplinary designer working at the intersection of society, technology, and the built environment. Prior to Google and Sidewalk Labs, Brian worked in architecture and urban design in the private and public sectors. He graduated with distinction from the Master in Design Engineering program at the Harvard Graduate School of Design and the School of Engineering and Applied Sciences. He studied previously at Columbia Graduate School of Architecture, Planning and Preservation, and he received his Bachelor of Arts from Yale University. I would like to quote a couple of words, your words, Brian. They capture my attention. I believe design creates joy, community, and justice. I love cities, infrastructure, and interfaces. I imagine better interactions for complex systems. My work combines machine intelligence, urban futures, and human-centered design. And maybe later we can comment on that. But for now, please join me in welcoming Brian Ho. Thank you.
Thank you, Maria, and thank you to the Biennale for inviting me to speak. I'm really honored to participate in this conversation. So if you'll excuse me for 2 seconds, I'll try and share my screen. This is always the hardest thing to do. And I will tell you that I work in technology, but even we struggle. I'll get going, and I'll try and give ample pauses for the translation. But again, really excited to be here. I think my biography has already been stated, so just to say it again, I am a designer, but also a technologist and an urbanist. I trained in architecture, but now work as a product manager at Google. My work is really at a range of scales and mediums. So systems for cities, buildings and architecture, and most recently digital software. One thing I'll just say is, as my career has sort of advanced, so too has the number of words it takes to describe the things that I do. So hopefully today I can summarize some of the more interesting pieces for this audience in as few words as possible. And so we're not dragging on too long. One thing before we begin any further, would just love to emphasize that much of this work was created with others, if not all of it. And in all of those contexts, I'll try to give credit to those collaborators. If there's anyone I missed, I apologize, but working with others is, I think, one of the secrets behind the scenes for getting stuff done. Okay, so with that, I will start, and I'm happy to hopefully save some time for discussion at the end. So maybe just as a thesis, I wanted to spend some time trying to retroactively construct some kind of common theme for this work, appropriate for a talk about design and change. I'll just say that post-rationalization is something that I learned very well in architecture school and is another sort of trick of the trade. One thing that sort of caught my eye when I was sort of preparing for this is I noticed that I had been previously categorized under tools and then later was moved to solutions. I think this was an artifact of scheduling, but in any case, I sort of asked my colleagues humorously, what is a tool if not a solution, right? What is the point of a tool if it doesn't do anything? What's the point of a hammer without a nail? And I think the response I got was something like this: a tool without a solution is a useless machine. So I think that was a good reminder of that. So I'm hoping that I'm not a useless machine, but I do say that in a lot of my work, I'm always wondering about the why, right? So why build the technology? Why use it? Why leverage these techniques? And so a common thread really here is the negotiation between a joy that I have for making tools and a desire that I've learned to apply them as solutions in a variety of contexts. I've been thinking a lot about Bruno Latour in light of his passing, and I'm remembering when I first started that I was so excited about the idea of a social construction of technology and a correspondingly critical practice of technology in design. And that's something that I would love to sort of maybe try and talk through today. Design and technology are tools, yes, on the left, and they let us create solutions, which are perceptions, decisions, and behaviors. And that's, I think, maybe the common theme that we will try and uncover as we talk through a few projects. Okay. So forgive me that preamble. We'll start reviewing some work. So in 2017, I was a summer fellow at the Mayor's Office of New Urban Mechanics in Boston and working in partnership with the Age-Friendly Boston Project. So for those of you who do not know, the New Urban Mechanics are a civic innovation group within the city of Boston. They apply both experimentation and evaluation to improve government and civic life. It's a fantastic organization, and I really encourage everyone here to read more about them, to find ways to collaborate, or just take inspiration from the really cool things that they've done and will do. I think for them, design and technology, again, are these tools combined with a fundamentally entrepreneurial spirit. And these are how they get to solutions for their city. So in working with them, the challenge that I was presented with was really to increase access to public space for older adults. And that challenge started with simple observations and conversations. So I spoke to older residents in the city of Boston to understand needs and experiences, and I worked with others to build on their research and work. One of the insights here was that access to open space depends on individual mobility, and mobility depends on having a place to sit. And so the thing you're seeing on screen here is just a recording of a walk from a bus station to a senior center. And in this walk, there's in fact only one bench that is right there. And the rest of the walk is essentially sidewalks without affordances for sitting or any other kind of stopping. And so it's a very, very long walk, especially if you are an older adult. I took this observation at the street scale and then looked at it from the city scale. And I began to map here in red the locations of benches across the city. I also mapped here in blue where older adults lived, right? Did they live in buildings or apartment complexes? Where were there sort of more density of older adults because of different kinds of communities? And then I overlapped those two layers together. And I think one of the interesting insights you get here are, there are some places where there are many older adults and relatively few benches. And those are great places to think about intervention. And I think in that way, mapping is a tool, but maps also become solutions when they are useful, when the information contained within is something that is actionable. And so I think one thing that I'm quite happy about is, well, after I finished, the city of Boston and the New Urban Mechanics partnered on a bench program, and they actually installed almost 100 benches in areas of greatest need without the city. And here's then Mayor Marty Walsh cutting the tape on a bench in Boston. And I think it's just a nice illustration of at the end of the day, the real solution, the real tool is a bench, but there are many other tools that get you there. Of course, the thing you saw at the beginning was another kind of output of this process. And this was an SMS or a text service that lets you text your location to the bench buddy, and it would actually respond with a little map of the nearest bench. And so it was meant to be a way to explore that map, right? To make the map interactive, to interrogate it, to get back some information from it. And it was also a little bit fun. You could actually name the bench. So you could find your bench and then give it a name, and it would then forever be called Marty or something like that. So I think this is a nice example of some of those themes, and I'll move forward to another project and we can see how this plays out. So maybe another thing to talk through is House Zero. This is what you're seeing on screen. It looks a little bit magical. It's a augmented reality display for a sustainable building. And so again, here's this idea of using a tool, data and a solution, being able to see it and interact with it in one piece. Just a bit of background, the house you're seeing here, the House Zero, is the headquarters for Harvard's Center for Green Buildings and Cities. It's a retrofit of a single family home, and it's meant to demonstrate how even older buildings can be made sustainable through various kinds of interventions and best practices. One of the challenges that the researchers in this project were working with was that they just could not understand some of these very complicated simulations they were building. So they were developing a computational fluid dynamics, or CFD model, which you see here, which is essentially this cloud of arrows and vectors that demonstrates how air moves through the building. And it's very hard to understand what that is because it's essentially a three-dimensional matrix of information. And so putting it in front of your face as a display on top of the world was a solution to this problem. And it let the researchers understand these microclimates, control the building, and understand performance changes that would result. And one thing we talked a lot about in this work was this goal of making the invisible visible, right? That we could somehow superimpose on top of the real world an understanding of what could be or what was actually happening behind the scenes. And that's something you hear a lot, right? Let's show the things that are hidden. And I think it's an interesting point, and my take is that visualizations are most helpful only if you can take action, if you can actually see something and do something about it. And so for that reason, much of this project was about interaction, that a user could change the thermostat or open a window and use that to understand the difference in the sustainability of the building overall. And I think the end result is quite a useful prototype. There were obviously a lot of complications as we did this work for the first time with the center, but it was a great way to explore these ideas, and I think was ultimately quite persuasive for illustrating some of these larger points and themes. Okay, so let's see, I'm doing time. Doing just fine. Maybe another project to speak to really is this academic thesis that I created called the New City Image. So it follows similar themes about, speculative investigations of perception, but also linking them back to tools. This is academic research, and I've sort of described this practice as computer vision cartography. And so what this really is the idea of using the tools of the trade, so digital mapping, cameras, data from a variety of sources, and applying them to new applications, really ways of mapping human perception and understanding of the urban environment and urban design. So one thing just to say is that when I started this work, I sort of observed that typically a lot of these tools are used in a very, very data-driven manner. And so what you see here on screen is a good example of that, right? It's all about the plan view. It's all about creating this overwhelming sense of information and tracking and recording. And yet somehow it also misses a lot of what we care about as humans about the city, right? This version of the city, which is entirely from the God's eye view, is really not that helpful in linking us back to the things that make cities important, whether that is, the sights or the sounds or the smells of a specific street or neighborhood. And so what I wanted to do in this work was really start to explore other ways to think about it, right? To make this point that what you have on the left, the plan view, is really not equivalent to the street view in terms of what we've been able to do in both history and contemporary practice. The plan view is scientific, it's analytic, it is remote sensing and all sorts of GIS technologies. And the right is scenographic, it's imagery, it's evocative, it's representational, it's film and movies and all the things that we really can derive emotions and joy from. And the question for this work was really, can technology bridge this gap? Can we get closer to the human's version of the city? And so this is just a diagram of the same kind of thought, that a machine could sit in the middle between humans and the built environment, but actually begin to convey some of the more qualitative aspects of the city. So the work really took 3 parts. I'll talk through them in order, and some of them are a bit longer than others, but I think it's a nice way of unfolding some of these ideas. So part 1 was really inspired by Kevin Lynch, the kind of urbanist who worked at MIT in the kind of 1950s and 60s. He did some groundbreaking research in Boston where he was able to identify this idea of city elements, right? So if folks have seen this or have not, Lynch's thesis was that you had all of these different parts of a city, the path, the edge, the district, the landmark, and the node, that had distinct perceptual qualities. A path was a way to get from point A to point B. An edge was a border or a perimeter. A district was something that you could be within and felt like home. A node was sort of a center of activity and circulation. A landmark, of course, was something visually distinct. And he recorded a lot of these elements in 3 cities in his work, using ethnographic and anthropological or social methods, speaking to others, taking walks with them, recording this. And he built out quite an amazing data set of images. But ultimately, this work was manual. It was done by hand. It was done through conversations. It was done through singular points of observation, and was groundbreaking and is still quite influential for urban design practice. But my question was, can we extend this using technology, right? This could be one of those ways in which contemporary tools get us to new solutions, that we might be able to take Lynch's work, which you're seeing here and all of his archival imagery, and extend the map, as it were, and build out a much broader understanding of Boston. So to start, I took his archival images, which were hosted online by MIT, and I used them to sort of create a data set of essentially things that a machine could learn from. So I was able to basically reproduce this map, which Lynch had drawn as a diagram, and overlay it on top of the city and his photos, and then use those photos, which had now been labeled, to train a predictive model. And so, the data itself is really interesting, right? Exploring some of this just on a map is really powerful, and this kind of maybe is reminiscent of some of the first work that I spoke to. Just putting things on a map is really interesting, but where I think the project really began to come together is when the model began to guess where the images were, right? So what you're seeing here are images on the left where the computer is guessing that it's a district, that there's something about the image or the plan that feels like a district. And on the right are all the images that the model says, no, these are not districts. These are something else, and they are not part of this categorization. This technology back in the day was, for me, quite advanced. I think what is astounding to me today is that in 2022, it's gotten, light years more advanced, and this is pretty rudimentary by all contemporary standards. But I think at the time it was and is quite interesting from a designer's point of view. You can see similar sort of exercises with things like landmarks. So if you look on the left, these are all images which the machine thinks are landmarks, and on the right are images which it thinks are not. And there are some interesting patterns, right? So landmarks tend to have a bit more white space in the figure ground diagram. On the images themselves, you see more of the, Copley Square and the church, and you see some of these longer views. So there are certainly sort of features that maybe the model is identifying. And really, I think one of the funny things here is, from my perspective, you don't know why it works. It just sort of works, and then sometimes it doesn't. But that's a discussion for another day. And then finally, I think, another sort of insightful view is images on the left, which the model thinks are either districts or landmarks, and on the right being things which are not. Sorry, on the left are both, on the right are neither. And again, you see similar sort of patterns where the right-hand side tends to be less dense, and the left-hand side tends to be more dense. And there's other things that you can sort of stare at and wonder and sort of imagine that a computer is beginning to understand some of the things that we know intuitively as humans. So that was part one, which is really to kind of extend this work of Lynch through computer vision, and some of this work has been published in Acadia. But there were also parts 2 and 3, which were a bit more modern in their focus. So the next steps for me were to basically reproduce this work with images of my own device. So I was able to build some tools. Again, this love of tools and joys of making them, it came through, and construct a device for my bike where I could capture 360-degree imagery of the city of Boston and use that as my own data set. So rather than use Lynch's training data, I could use my own data and construct an equivalent data set of modern Boston on the same streets, but 40 years later or so. And so this in itself was quite an adventure. I think I went through 3 or 4 bike tires in doing it, but nonetheless, it was a good way to build your own data. And I think one thing that I'll advocate for as a practice for designers is we should not take for granted the kinds of data that goes into our tools and our computers. I think building your own understanding of the ground condition has always been part of the study of a site and planning, but in the modern age is equally important when we think about machine learning models. We have a responsibility to think about the data we create and the data that we put in into these tools and technologies. And so the next steps for this process were sort of similar to before. I had to basically label and identify all of these data sets. So I built a little tool for myself to do that. So here's a way to take an image that I had seen and match it to another image. And then the next steps to follow were really about following through, right? Allowing others to interact with this data set, to explore their own map, and to understand this modern understanding of the city of Boston. Maybe just to close on this work is just to say that what I found most interesting about it is that it didn't just have to be passive, right? It didn't just have to be that the model was trying to understand what the city was. the model could try and understand what the city could be in the future. And so some of the more interesting experiments here were actually collages, where I would basically create net new scenery in the city environment using elements of Lynch's own design, and then see what the model would think. And what you see here is that after a certain point, the model decides that you've created a district. You've added enough street wall and urban form to the picture to actually create something which is now a district from something else. Here's another example where you have something which starts out as a sort of junkyard and then also becomes a district through sufficient layering of other imagery. And so it's a nice way of testing what the machine thinks and seeing that the machine seems to also understand a bit of what we understand in the built environment. Okay, so we've talked through a few, prior projects. I think what I'll spend the rest of the time speaking to is what I'm working on today. So what I mentioned at the start of the talk was that I now work at Google as part of Sidewalk Labs. And one of the things that we care a lot about is, advancing the conversation around cities and seeing how they might be better through new tools and solutions. So one thing that we had tried was to explore future prototypes for streets, right? To understand what streets could be like in the future if they weren't just for cars, if they were in fact for people. And part of that exploration was actually the construction of a complete physical prototype of the street of the future. You see it on screen here. It's the plywood platform that everyone is standing on. It's actually made up of individual hexagons, which represent future tiles. And each of those tiles has a little LED light, and those lights are controllable, and they allow the street to take on different colors and schemes depending on its use. And so the street can be reconfigured from a pedestrian plaza to a two-way street for cars into something else entirely just by pressing a few buttons. And so the thing that I worked on was this question of, well, we've got this amazing prototype, but it's just on the ground. How can we really let someone understand the street of the future? And so the question was, how can we project some of this additional construction that we certainly cannot build, like buildings and street furniture and other elements on top of the platform that we had? And the answer again was augmented reality, this time using an iPad. And so the tool here, built with a few others, was a way for someone to stand on the street and understand on top of it some of the additional things that might be built, the architecture and the built environment of the future. And so, this included things like people and buildings and trees and plantings. But one of the things that I was really fond of was we included on top of it some autonomous vehicle shuttles that you see kind of moving in and out of the foreground. And these AVs were actually smart enough so that if you stood in front of them, they would stop. And so they would know that you were there, and they would defer to the pedestrian, and then they would wait until you had left to move on. I thought that was a nice way of, exploring this idea of the future that, we need not bend the knee to cars, as it were. We can actually assume that streets are for humans and for people first, and that they're for cars second, and that, the technology of autonomous vehicles will actually enable this to be a much more compelling and safe experience for all of us. Here's a bit more of what that looked like from the ground level. And so you can see here how those cars are sort of moving around, and you can see the people in the foreground. And in this way, it was a fully interactive experience. I think this is also a video of a similar scene. So you can also see what you could see on that display. And you could pan around and see all these other figures and walk through the surface and actually see all of this material overlaid and actually move through it. And I think, to my knowledge, this is one of the larger augmented reality projects out there. So you could sort of walk around this 40-foot or so expanse and look fully around and understand what it would be like in the future. Another sort of interesting piece here was this idea that others could see. So collaboration is a big part of this work. And so what you just saw on the projector there was a little mini map, if it were, of the same view. And so even if you didn't have the iPad, even if you didn't have this augmented reality, other people could see what you were seeing through this overhead display. And so many people together could kind of share the same view of the future and imagine it together and talk about what that would feel and mean like. And so all of this was intended to promote a sense of community engagement in this work. Okay, let's see. How am I doing for time? I've got a little bit of time left. So I'll move on to, I think, the last thing, which is the most recent thing that I've been working on. So let's see here. I have most recently been working on Delve by Sidewalk Labs. And so here, Delve really is a software product. So if you're an architect out there in the world, or designer or developer, let's talk, because Delve is meant to be a tool for you. Delve's mission really is to radically improve the quality of life for all through holistic, qualitative, and transparent urban design, quantitative rather. And I think, from my personal work to this product, there's really a lot of overlap, right? We are trying to create a tool that achieves a solution. And for us as a team, the solution really is better outcomes at the urban design level, that we can build better places for people everywhere using tools of measurement and evaluation and thoughtful consideration. The Delve has always been a generative design tool. And so what that really means is we are trying to help people create designs when they don't have them. And so we can use technology to generate these options. We can use technology to then evaluate them. So we can actually understand how these options perform for daylight, for views. We can evaluate their financial performance. We can measure the number of units. And the most important thing is we can really scale this. So we can actually create many more designs than humans can create, and through that find better options for all of us. I think one of the problems we're looking to solve, so one of the solutions here is really this idea that our current processes are slow. If you want to learn from a building, you basically have to wait for it to be fully constructed. And that process takes years, if not longer, to understand. Another problem really is that there isn't a shortage of technology, but rather there's almost too much of it. There are so many different tools in the toolkits of consultants and design teams and engineering teams. And very often these tools are not speaking to one another. And it gets to be quite confusing and complicated to understand what's the right decision, because every time you make a change, it's got to cascade through all these different models. And it's almost like this game of ping pong where things just go back and forth and bounce off one another. And so the idea of Delve and the idea of generative design as a practice is that we can sort of escape all of this, that we can essentially evaluate our designs and see if they're good or bad, and do that across all of those models and really reduce that noise to a clear signal in just a few clicks and inside of this tool as a whole. And so one thing I think that nicely illustrates this point is we've been exploring the idea of generating many options for different blocks and seeing what happens. And I think we're also exploring ideas of optimization. I always really like using this slide because it sort of illustrates what happens. And so on the left, you see optimization without good results, where the model is just sort of pinwheeling and cartwheeling and just creating the same thing over and over. And then on the right, you see an option where the model is starting to find things of similarity that do well. I think in this case, it's really that tower in the bottom left of your screen. And then in the middle is sort of a fun one for me as well, because here the model has found what it thinks is a good solution, but that solution is really bad from a human's perspective. The solution is a ginormous courtyard that is the size of an entire block. And I think each of those buildings is something like 100 stories tall. And so, as a team, we've always used this as a good reminder to ourselves that in all the work that we do, the human, the user, the customer will always be really important, because they will ultimately be the ones that provide critical information to these tools. And again, I just want to stress, this technology does not remove the role of the designer or the creator. In fact, it puts even more emphasis on them making the right decisions, but it simply helps them along the way and gets us to better results. Some other interesting work from this, I think, has to do with similarity and understanding designs. And so technology is really good for generating things. It can also be really good for understanding them. And so what you're seeing here, these sort of wisps of data and scatter plots, are essentially all the designs, I think some 1,000 or more designs generated, and then mapped in a way based on how similar they are to one another. And if you zoom in, what you actually see is that we can actually organize these designs spatially. So we can actually understand designs which are smaller and have more buildings and more blocks against designs which are larger and more regular. And so if you just look at this grid, you can see that on the bottom left, you get some of the smaller designs, and on the upper left, you see more of the rectangular grid, and then somewhere in the middle, you get sort of things that are in between. And it's a really fascinating process to essentially watch a machine learn about design and then also wonder what it might teach us eventually in terms of the possibilities. But I'll just say that Delve is, of course, a software product. And, having been a designer and now working as a product manager, I've really enjoyed reapplying a lot of those skills into new avenues and working with others, of course. And so we today have a product that I welcome anyone to reach out if they're interested to try. Delve.sidewalklabs.com is our website. But we're happy to have folks give it a shot. And you're basically able to generate these designs and see these options and understand which are better and which might be worse. And there's a variety of metrics that we work on and that can be evaluated. And all of that, I think, is meant to serve this goal of empowering the next set of buildings and neighborhoods that we live in. Maybe just to close on this work, I'll just say that within Google, we're also part of Google's efforts to improve sustainability. We're part of Google's third decade of climate action. So they've been working on this for over 20 years now. And so a lot of our focus today is about using these tools to reduce greenhouse gas emissions, whether that's embodied or operational carbon, but also work with others and find good partners for pushing innovation forward and help make change. And I think, again, this is one area where I see technology being, really well suited to helping us achieve these goals and to become a solution where we're able to measure things. And if you can measure them, then you can improve them. And that's a way forward for both Google and I think for the broader world. So I think we're coming to about 1/2 and I think I might end there since I would love to have some time for conversation. But maybe just to close, I think where I started was we are talking about design and change. And for me, design is both technology and design itself, and the change you can make are perceptions and decisions and behavior. This maps very well to tools and solutions, and that brings us back to where we started. And so I encourage all to think a bit more of that and open the conversation to all of us, because I think it's one that I'd love to participate in and share with all of you. So with that, thank you all, and I'm happy to talk a bit more with the group.
First of all, I want to thank you for this exciting and impressive presentation touching such a variety of approaches, tools, and applications, and including also an overview of the use of technology as an activator of conditions for a more sustainable, places and for a better design approach. I would like to touch a little bit with you, and it's not really a question, we can just have a conversation about it. And I'm very curious about your comments on it, about generative design and artificial intelligence, particularly on what you want to achieve. What do you want the computer, the tools, the digital tools, the computational tools, generative design, these digital technologies and emerging technologies, what do you really know where you are going and what you want them to achieve for you? Is that kind of the approach that you have, or do you already know the path that you are starting when you have a problem or a question in front of you?
Yeah, it's a good question. And what I'll say is, as a team at Delve, I think we are very clear in what we want to achieve. In fact, we almost start from the mission and work backwards, right? So we know we want to produce better urban design for people everywhere, and we want to produce the tools that others can use to do that. And the machine learning and artificial intelligence are merely means to that end, right? So we only use them if they are applicable. And I think internally we discuss day in, day out, almost every week, is this the right solution for the problem at hand, right? Sometimes the simple things are the better things. And I think you'd be surprised how often we as a team realize that a simpler solution that is more easily understood is in fact better than a more complicated one that isn't. And I think that extends well into machine learning and intelligence. The other thing I would say more personally is, in my work, there is definitely a joy around just exploring these technologies and sometimes that joy is a joy of discovery, right? To be like, oh, I didn't realize that if you put these things together, this might happen. And I think that's very different, right? That's the joy that we all share as creators and designers and crafts people, that sometimes just, picking things up, putting them together, turning them upside down is fun. And through that, you learn new use cases. So it's a bit of both. But I would just stress that in the professional work, the work that we do as a company, as a product, we're very thoughtful about what to use and when. And if anything, what we've learned from our users and our customers is a simple thing is often better.
Thank you so much. Daniela, do you have questions?
Hi, thank you. Thank you, Brian. That was a really thorough presentation as well. I don't see any questions here from the audience, but I just wanted to ask in terms of that tool that you have, this Delve tool. In recent projects, like how has it been used in more recent projects that you've had? Like what were you able to come up with from this? What solution did you find using this tool?
Yeah, so the example that I actually was showing on screen was quite interesting. We were working with a customer in near London, and they were interested in trying to increase density, in part because they were able to increase the affordability of the project, increase the number of affordable units that way. But the challenge was, can we do that while maintaining the daylight requirements, the right to light, the access to open space? And so using the tool, they were actually able to generate a 15-acre proposal that achieved, I think it was on the order of 200 more units, but sort of preserved the same amount of open space and daylight access. And so, it looks very much like a normal development from an urban perspective, but I think the interesting thing is because Delve is able to go through all those options, you get a better option, right? You basically can, it's like picking a lock, and you can basically, turn the knobs until you get to the one that clicks.
Yeah, that seems to be like more or less a direct link to what you will come up with to be able to come up to a solution. And that sounds actually pretty good to be able to solve that without having to do so many layouts, like a simpler solution, or what the solution that we will be used to.
Yeah, I think that's right. And I imagine many of the folks in the audience are designers and developers and planners. We, and I, as a former architect myself, we know that the things that come out of the computer, you don't press print on them, right? There is no Control P and then it just appears. But Delve gives you the initial idea, the sort of sketch concept, the partie that you can then, take to Rhino or CAD or Revit and work on and develop completely. But that initial exploration, we've all seen the tables covered in foam models. I guess the answer is there could always be more foam models, and Delve is able to make that table ever bigger.
I also would like to ask you, Brian, about your collaborative efforts with communities, and when you are responding or facing or questioning pressing challenges in planning cities or neighborhoods or environments that are, vulnerable, and they need some sensitive approaches. So how do you work? What is your, daily activities when you have to face a collaborative approach?
Yeah, I mean, admittedly for me, this is a skill that I'm learning and one that I'm no master of. And I think I've been very fortunate to work with folks who are much more established in community engagement and practice and learn from them. I think maybe just to speak more generally to collaboration, as my career has gotten more ambiguous, if I may, where the thing that I do is less clear and it's in stark relief to others who bring expertise to the table. I think what you learn is you learn the limits of your own knowledge, and you learn that listening is often the more important piece, right? If you can understand perspectives and insights from others, then your role can be one of synthesis or navigation or connecting the dots, rather than being the one with all the answers, which I am very much not. So I think that applies to community conversations. Again, there I'm no expert, but I think it's a similar thing where you listen as much as you speak.
Thank you so much.
Yeah, we do have one more question. It says, what potential concerns are there about machine learning AI with generative design?
Yeah. So one thing that I'll just say is I'm incredibly interested in machine learning as a tool, and I think of it like other tools where we have always been thoughtful about the way we use the tools of architecture, the tools of urbanism, the tools of planning, and those must continue. And I think we can't, give those up now that we have ever more sophisticated tools at our disposal. And that really is what I'm kind of interested in. And I think we're seeing that today. And the other thing I'll just point out is, this notion of a generalized AI isn't really what we're speaking to. What we're really speaking to are tools that serve a very specific application. And that's what is actually most exciting for me, is that we can craft and build these things that do a thing very, very well. And those are, like anything else, things that we have to be thoughtful about.
Okay, thank you. We have one more question. Can these massing profiles also provide energy performance in the context of the 2030 and 2050 commitment?
Yes, it's something we're actively working on today. So we'd love to my earlier comment about tools, make a tool which lets you understand the energy use intensity or the embodied carbon footprint of a design based on its profile. And we're ever seeking partners on this, but I think it's something that I see as incredibly promising for this technology in particular, right? If you can try all the shapes, you can find shapes that'll eventually get you to hopefully zero carbon, if not better.
Thank you.
Thank you very much. I think we are reaching the end of your time. We are delighted to have you here, Brian, and thank you for the wonderful presentation.